Hello folks and welcome to another overview of KStars and Ekos. I'm going to be talking about the next minor revision of KStars 2.4.0. In this release we have a few changes, most notably in Ekos, as you would have expect, and they're mostly tailored to those who are doing astrophotography. First thing, a few folks complained that navigation within Ekos various tools can become cumbersome at some point because we have Ekos Manager, we have NT Control Panel, the Fits Viewer, etc., and they can be located at different taskbars or across different virtual desktops, and it's hectic to find where they are exactly. So now there is this small toolbar here which has all the essential tools and whether they're displayed or not. So it's like a toggle, you can toggle. So you can toggle Ekos on and off. The button now is already toggled. And if you close Ekos, it's untoggled again. So it gives you the state whether they're displayed or not. So this icon here this is for Ekos, this is for ND Control Panel, the Fits Viewer, and the Device Manager. And you can see the Fits Viewer and ND Control Panel are disabled because we don't have anything running right now. So if you go to Ekos Manager, we see here a little bit of change. We see more devices. Notably, we see the weather device. This is the new addition in ND version 1.1, which will be released very soon. And here there is a sample driver, the Wunderground driver that I wrote just yesterday actually, and it communicates with the Wunderground weather API, and it downloads the site, the weather information for the site you're located at. You need to register for a Wunderground API key if you want to use this driver, but it's available for free. You also see that we have now an additional fourth auxiliary device, so you have a total of 4. And your auxiliary device can be your webcam, your joystick, your Arduino controller, or what have you. And as far as the weather goes, all weather devices in the future will try to sum up their condition either as OK, which means go on, continue the observation, or warning means be cautious, there are some problems, or alert, which means it's time to go into panic mode and close everything up. So this is the basic theory now behind the weather device and how it relates to the various Ekos modules. Next, you see here that we have the Scheduler tab, which you guys probably foresee it here for the first time. So the scheduler was started as a Google Summer Code project, and then I took over and rewrote pretty much the whole thing to fit with Ekos coding standards. And the scheduler is meant for those who want to perform unattended observations, unattended either local or remote observations. So this is the goal of the scheduler. It schedules your object, selects which is best to image at what time, and it performs all the functions so you can get your data. If you usually sit next to the PC or the client when doing astrophotography workflow, then you don't need to really use the scheduler. You can just use Ekos and do that directly. But if you want to just take a batch of images at the night, and you want everything already, if you want to wake up in the morning, everything is already captured, and the mount is already parked, and if you have a dome, the dome is already parked and closed up, so you don't have to worry about it, then this is for you. So let's talk shortly about what do you do in the scheduler exactly. The interface is similar to the CCD modulo. We add jobs here to this list, and then we execute the scheduler. And so what you need first a target. So let's select any random target, for example M31. And optionally you select the fits file. If you select the fits file of, for example, M31, it will send it to the astrometry solver. If you choose it here, if you choose online here, it will send it to the astrometry solver, and so we will align to this fits image exactly. Otherwise, we will just align to this right accession and declination. Next, we have the Ekos sequence file, which is a collection of jobs in the CCD capture modulo. And if you don't know what that is, then you need to watch my previous videos on Ekos imaging workflow to see what the sequence file is. So the sequence files contain how we do the imaging, how many sequences, how many counts we take per image, what kind of filters, what's the CCD temperature, what's the naming prefix, etc., etc., etc. And here we choose the modules we wish to use with this specific observation job, and they are actually in order. So if all of them are selected, we perform autofocusing first, followed by astrometry, followed by guiding, and when all of these pass, the imaging process, the actual capture process takes place. And of course we can mix and match between these. We can, for example, only do astrometry and then go directly to the imaging part, or we do astrometry and guide, or we do focus and guide and then capture, any way you wish. And here we have the weather checkbox. So if you check this box, it will monitor the weather. If you have a weather device like the underground driver or a local weather station, and it makes sure that the weather is okay. If the weather is not okay, it gives you a warning, and if the weather is really bad, it will execute the shutdown procedure here, which we'll talk about shortly. So as soon as you, let's select the sequence file here. So I have one here. So as soon as we select the target and the sequence file, we have three things to fill out. The startup procedure, which as the name suggests, when do we start up imaging, or when do we start up the procedure for imaging this target. So the first default option now, which means as soon as possible, ASAP, just make sure all the conditions and constraints are met and then start imaging it. Or we can choose culmination offset. So culmination is the highest point a target can reach in the sky, and we can specify an offset by default 60 minutes prior. It's negative, so 60 minutes prior to the culmination, start imaging. Or we can specify a specific date and time if we want to. The constraints are pretty simple. We can specify a minimum altitude. So we can specify an altitude of whatever, and it has to remain above that during the session and when we're doing the scheduling. Same thing for the moon separation. If we select this checkbox, then the moon separation value must be respected. And here we select if we don't desire any meridian flip, then we just check this box. So the completion condition is simply as it says, when do we complete the job. So by default, when the sequence file, everything within the sequence file completes, then we're done. We can also select loop until terminated, so it will reset the sequence file and it will keep going, keep executing the sequence file again and again until it's manually terminated. Or this option is loop until a specific time. For example, execute the sequence queue for like 5 hours and then terminate it. And here we have two important things. They are not related to like each job. This is for the overall scheduler. So this is a one-time procedure, one-time startup procedure, and one-time shutdown procedure. The one-time startup procedure is composed of two parts. It's composed of the startup script and these options here, which are now just two, which is on-park mount, on-park dome. The startup procedure, we have a startup script which runs first. If selected, you can leave it empty. But if you have a startup script, it will run it first. And we need the startup script because Ekos and NT cannot cover everything. There are devices outside of the scope of ND and Ekos, and the conditions which must be met before we start up the observatory. For example, we might need a startup script to turn on the power to the equipment, or to turn off light, or to heat up something, or whatever. Each observatory is unique, right? Here I have a a sample Python a startup script. It's a very simple one. It just prints statements and then sleeps for 5 seconds, and it's exit with 0. Exit with 0 means it finished okay. It finished fine. And these statements here are also echoed back in the Ekos logger when it's executed. So after the script is executed successfully, then unpark mount and unpark dome, if selected, they will be executed. The shutdown procedure is similar. When everything is done, or if the weather is bad, it will execute it. But in this instance here, these things, these checkboxes, warm, CCD, park mount, park dome, are executed before the shutdown script. So the shutdown script is the last thing that runs. Again, we can also make it turn off power or do whatever we want. It's completely up to you to do what you want with it. Okay, so enough talking. Let's just see the scheduler in action. Of course, this is all under simulation, as I'm building my observatory right now. It will take me a couple of months before I can get it ready and up. And once I get it ready, hopefully I will demo this scheduler again live. So let's go to the observation planner, and I already selected a few objects here. M31, which is what you already have here, and it culminates around it's 140. So if we put it 60 minutes, that's 1240. So and here we have an option which is add to Ekos Scheduler to just replace whatever in here. Okay, so let's add the first one, M31. Let's go add M33. So it's already put it here. Same conditions. Vega, Vega is setting slowly right now, so let's add it there. But instead of culmination, we will say, because if we say culmination, it already culminated, it already crossed this one. So let's just say now, and let's see how it schedules it. Let's go to Spica, and Spica is a unique case because it's already below the horizon. And not only that, because if something is below the horizon, Ekos will try to schedule it the next day, or the next time it rises and in dark skies. But Spica doesn't actually rise above ground at night. It's only during this time of the year it rises in the day. But let's see what how Ekos behaves to this condition. And here is Arcturus, and it's now about 9 degrees, so that's very low, but let's add it anyway. Okay, and we didn't specify any altitude restrictions, so whatever altitude is fine. And now if we start the scheduler, a lot of things will happen quickly, and most likely the startup script will kick on because we have Vega, which can be imaged right now. So also Arcturus. The Arcturus is very low. If you double click on an object, you see that it says editing job 5. So we can edit this job and then click this check mark and apply the job changes. So let's go to Arcturus and say we need the altitude to be 30 at minimum. Okay, so now the scheduler has because now it's going low. Let's see the scheduler, what will it do if we put an altitude restriction of 30. Okay, so let's start the scheduler now and see what it does. Okay, so a lot of things happened very quickly. Okay, now the startup script is running, and the job candidate is Vega. Okay, already Ekos started, and the control panel started, and it's slowing to Vega. So let's go and see where the telescope simulator is, and there we go, it's going to Vega. And here we see that it marked Spica Okay, so it's already, this is very fast. It's already finished focusing and astrometry for Vega, and it's doing the calibration for the guiding now. It already marked Spike and Arcturus as invalid because we can't get, I think, Arcturus above 30 degrees. Let me see that. Yeah, even at night here, we can get it above 30 for a very short period, which is around dusk here. So so that's not suitable. Not suitable this time of the year. Spike is the same thing. Okay, so now back to Vega. We're doing capturing already. And we see here M31 is scheduled almost 12:40 to 12:36, and M33 is 1:30 a.m. And we're done with this Vega job. And we see here, because it's a bit smart, it says M31 observation job is scheduled for execution at Sunday, whatever, parking the mount until the job is ready. So now the mount is being actually parked as we okay, it's already parked now. So now the mount is parked, and Ekos will simply wait until 12:30 a.m. and it will go to M31. So since we're doing this in simulation, let's also simulate the time. We're not gonna wait till 12:30. So 12:29, or let's say 12:35. Okay. Oh, but that's today. I didn't put tomorrow. Yeah. Okay. So now it unparked the mount and it's slowing to the target. And here it says the weather conditions are okay. Let me go ahead and make the weather conditions warning. We can here change the parameters. Each parameter has a minimum and maximum value for okay and warning. Anything outside warning is going to become alert. So for the temperature, it's now 33. Let me put the maximum okay as 30. Okay, so that's supposed to be warning. Okay, so it's still slowing to M33. Sorry, M31. Okay, now it's doing the focusing. Let's look at. Okay, it's doing the astrometry solving. It's done. And now it's doing the calibration for the guiding. And as you can see, this is all automated. No human presence is necessary. This is all being taken care of. Okay, so now we have a warning. Weather conditions are in the warning zone. It's a bit repetitive, but at least we get a warning. And the icon, actually, this is not correct. I'll have to look into that. Okay, so now we're starting capturing 31. I think we're almost done. Let's go to the CCD modulo. Let's look at this also guiding. Yeah, and we see here it's doing the in sequence focusing as well. We're almost done. Okay, So this is complete, and it's also now parking until the next job is ready, which is about an hour from now. If it's within like 5 or 10 minutes, I think it will not park, it will just wait. But if it's within an hour, so let's say that we have a thunderstorm that's coming in during this period. So let's simulate bad weather. It's actually now good weather. So let's say that 34 is a 33. So the maximum for the warning is 32. Oh, this is, sorry, here. Maximum for warning is 32 degrees Celsius. So the maximum for OK is 30, and maximum for warning is 32. Anything above that would be bad. So we click that, and now the temperature here is in the danger zone. It reports that, and Ekos check. It doesn't check every second. It checks every 1 minute. It depends on the value here. So in less than a minute, Ekos will figure this out and will try to go into shutdown mode. So let's just wait and see. Yep, it says here subject shutdown due to dangerous weather. Okay. The script was executed, everything was turned off, the devices were disconnected, and everything was parked. Well, the mount was parked already, but it issued the command anyway. And M33 is aborted. So there it is. This is a simple quick look on the Ekos Scheduler and what it does. You will see all these changes in the next revision of KStars. So I hope you guys find this useful, and good luck in your astrophotography sessions.